astronomers record anomalous activity on the Sun. A series of powerful coronal mass ejections could head straight for Earth in the coming weeks. The magnetic field of our planet can shudder under the impact of the solar wind. What scientists have been warning about for the past 50 years may begin. The Earth's upper atmosphere may begin to expand. The thermosphere, which normally extends to an altitude of 600 kilometers, is capable of swelling to nearly 850 kilometers. Oxygen and nitrogen molecules, heated by solar radiation, will rise into orbits where thousands of satellites and space debris have been flying for decades. The first to collide with the atmosphere will be old satellites in low orbits. They have been flying at an altitude of 650 kilometers since the 70s of the 20th century. The thin, almost invisible atmosphere will hook their solar panels. Air resistance, which is now almost zero, will suddenly become a real force. Orbits will begin to descend. Space agency engineers around the world will look at monitors with growing alarm. Computer models show a catastrophic scenario. Over the past 60 years, humanity has launched more than 15,000 satellites. Most of them stopped working a long time ago, but they continue to hang in orbit. They turned into lifeless pieces of metal orbiting the Earth at a speed of 7.5 kilometers per second. All these objects will fall into the zone of increased atmospheric braking. Every day, the orbits will be lowered by hundreds of meters. The process will speed up. The lower the satellite falls, the denser the atmosphere around it becomes. The denser the atmosphere, the stronger the braking. It will be a vicious circle. Space agency specialists will sound the alarm. Their radars will record the anomalous behavior of entire groups of satellites in low Earth orbit. Hundreds of objects will begin to descend at the same time. Calculations will show that in 2 weeks they will enter the dense layers of the atmosphere and burn up. But this will only be the first wave. Kessler Syndrome, which the American scientist Donald Kessler predicted back in 1978, will begin to work in a new way. Typically, this syndrome describes a cascade of collisions in orbit. A single debris crashes into a satellite, creating 1,000 new debris, which creates new collisions. Explosive chain reaction. Now the catalyst will not be a collision, but the Sun. The expanded atmosphere will act as a giant braking system, capturing thousands of objects at once. Engineers have calculated, in the next 3 months, about 2,000 large objects may enter the atmosphere. The total mass of the falling metal will exceed 500 tons. Each satellite, entering the atmosphere, will turn into a shooting star. But unlike natural meteors, which usually burn up completely at an altitude of 80 to 90 kilometers, space debris is much larger. Satellites weighing from 50 to 5,000 kilograms will leave bright traces in the sky. Some fragments will reach the Earth's surface. The International Space Station is located at an altitude of 420 kilometers. Still safe. But the expanding thermosphere will approach it as well. Space program managers will make an emergency decision. The station will need to be raised higher. Cargo ships will turn on their engines and begin slowly pushing the ISS into a higher orbit. Each maneuver consumes precious fuel. Satellite operators will face an unprecedented crisis. Commercial satellites that provide internet and television broadcasting fly at altitudes from 500 to 1,200 kilometers. Many of them are still working, but their orbits will also begin to decline. Companies like Starlink will lose 10 to 15 satellites daily. communication in some parts of the planet will be interrupted. Military surveillance systems will be particularly affected. Reconnaissance satellites flying in low orbits for detailed imaging of the surface will be the first to get into the risk zone. Military departments will announce a high alert mode. The loss of space-based early warning systems will make it impossible to track ballistic missile launches. The world will become less predictable. Amateur astronomers all over the planet will witness an incredible spectacle. Every night, dozens of bright strikes will cross the sky. These are not meteors. These will be satellites burning. Some will fall apart in flight, creating cascades of lights. One such cascade can be seen from Western Europe to Asia. Meteorological satellites weighing 2,300 kilograms will break up into dozens of large fragments, each of which will glow brighter than Venus. The physics of the process is cruel and beautiful at the same time. At an altitude of 120 kilometers, the atmosphere is dense enough to create monstrous friction. The satellite, flying at 7.5 kilometers per second, collides with air molecules so often that its surface heats up to 2,000 degrees Celsius. Aluminum melts at 660 degrees. Steel at 1,500. Titanium lasts longer, but it will not withstand such temperatures. The satellite will start burning. Solar panels will be the first to come off. They are too fragile. Then the antennas will be destroyed. Inside the sealed compartments, the pressure will increase from heating, and the case will explode. Thousands of small fragments will fly apart. Each fragment will leave its mark on the sky. You will get a luminous cloud stretching for tens of kilometers. Ground tracking stations will record everything. Radars in North America, Europe, and Asia will work around the clock. Engineers will try to predict where large debris will fall. Most will fall into the oceans. The Pacific Ocean will take the brunt of the blow. But some fragments will reach land. In remote areas, farmers will find debris the size of refrigerators in their fields. The metal will still be smoking. The examination will show that these are parts of the fuel tanks of satellites launched 10 to 15 years ago. They have flown for years in orbit and will end up in fields and forests. Debris will break through the roofs of abandoned buildings. Fragments of solar panels will stick into the ground next to the roads. Fortunately, there may be no major casualties. But the statistics will be relentless. The more objects fall, the higher the probability of hitting a settlement. Scientists will quickly realize the sun will not calm down. The active phase of the solar cycle will last at least another year. Perhaps 1.5. All this time, the atmosphere will remain expanded. The thermosphere will capture more and more objects from orbit. Calculations will show a frightening picture. By the end of 2026, no more than 3,000 objects will remain in orbit. The remaining 12,000 will fall. The sky above the Earth will be strewn with shooting stars every night. Meteor showers, which used to occur several times a year, will become a constant phenomenon. Only these will not be meteors. It will be a space-age legacy coming home. The space industry will be on the verge of collapse. There will be no point in launching new satellites. They will simply burn out in a few months. Insurance companies will stop covering space missions. Investments in space startups will fall to zero. Companies that build their business on satellite services will begin to go bankrupt. But nature abhors a vacuum. Engineers will look for solutions. Several teams will propose the concept of active satellites with powerful engines. Such devices will be able to constantly adjust the orbit, compensating for atmospheric braking. But this will require huge fuel reserves. The cost of operating such a satellite would exceed all reasonable limits. Another idea is to move critical infrastructure to higher orbits. The geostationary orbit at an altitude of 36,000 kilometers will remain safe. The thermosphere will never reach there. But putting satellites into such an orbit requires 10 times more energy. Missiles are becoming more expensive. Delivery time increases. Space agencies will propose radical plans. They'd want to launch a series of tugboat satellites that would capture falling objects and take them into graveyard orbit. A special high orbit where garbage could lie for centuries without disturbing anyone. But the technology to capture space debris is still in its infancy. It takes years of development. And there will be no time. Every day, 20 to 50 objects will fall to Earth. Some days will be especially busy. The sky over the northern hemisphere can be illuminated by 100 or more falling satellites at the same time. These will be massive waves. Groups of old navigation satellites will reach a critical altitude at the same time. They will enter the atmosphere within a few hours. The sky will burn. Social networks will explode with photos and videos. People will take to the streets at night to watch the rain of fire. It will be beautiful and creepy. Beautiful because the glowing stripes in the dark sky resemble fireworks. Creepy because each lane will mean the end of a multi-million-dollar project, years of work by engineers, lost communication and navigation capabilities. Navigation systems will begin to malfunction. GPS will lose satellites. The European Galileo system will lose a quarter of its constellation. Other navigation systems will be cut in half. The accuracy of determining the coordinates will drop from meters to tens of meters. For ordinary users, this will be inconvenient. This will create serious risks for aviation and maritime transport. Airlines will return to the old methods of navigation. Inertial systems, radio beacons, visual orientation. Pilots who are used to relying on GPS will have to remember the skills of their predecessors. Sea vessels will turn on astronavigation. The captains will take out the sextants that have been gathering dust in the storerooms for years. Humanity will temporarily go back half a century. Scientists will continue to study the phenomenon. The data will show that the expansion of the thermosphere will not be uniform. The atmosphere will swell unevenly. Above the equator, it will expand more than over the poles. This will create complex effects. Satellites in inclined orbits will experience alternating braking. Their trajectories will become eccentric, unpredictable. Mathematical models cannot cope with such chaos. Computers will calculate the trajectories of the fall, but reality will constantly deviate from the forecasts. Atmospheric disturbances, solar wind, magnetic storms will add randomness. It will become almost impossible to predict exactly where a particular debris will fall. It will only be possible to indicate a wide zone, from such and such a latitude to such and such a latitude, between such and such longitudes. Governments will impose restrictions. In some regions, air travel will be banned at certain hours when large objects are expected to fall. fishing vessels will receive warnings not to enter certain areas of the ocean. This paralyzes logistics. Cargo planes will not be able to fly on schedule. Delivery of goods will be delayed. The economy will suffer. Insurance payments for damage from space debris will reach billions of dollars. Companies that operate satellites will be held legally responsible for their crashed satellites. But many of these companies have long gone bankrupt or were absorbed by larger corporations. Lawyers will try to determine who should pay for a 30-year-old satellite that broke through the roof of a house. The international law of outer space will not be ready for such a scenario. The United Nations will convene an emergency session. Delegates from space powers will discuss measures. They will propose to create an international compensation fund. They will insist on tightening the rules for launching satellites. They will require mandatory disposal of satellites at the end of their service lives. They will talk about a joint monitoring and warning system. Discussions will go on for months. And the sky will continue to burn. By the end of the summer of 2026, more than 4,000 objects will fall. The Earth's orbit will gradually clear. But this will be cleansing by fire. Decades of space advances will burn up in the atmosphere, leaving only bright streaks in the night sky and piles of charred metal on the planet's surface. Astrophysicists will begin to study the long-term effects. A huge amount of the burned metal will settle in the upper atmosphere. Aluminum, titanium, copper, nickel. Microscopic particles of metal oxides can affect the chemical composition of the stratosphere. Some scientists express concerns. Will this cause climatic effects? Metal aerosols can reflect sunlight and affect temperature. But there is not yet enough data for accurate conclusions. The space community will learn from mistakes. A new generation of engineers will develop satellites taking into account the possibility of controlled deorbiting. Each new device will need to have enough fuel to descend on its own at the end of its life and burn up over the ocean. International standards will become stricter. The era of uncontrolled pollution of near-Earth space will come to an end. By the beginning of 2027, solar activity will begin to decline. The thermosphere will slowly shrink, returning to normal size. Falls will become less frequent. From 30 to 50 objects a day to 10, then to 5. By spring, there will be only a few drops per week. The crisis will subside. But the scars will remain. The Earth's orbit will change forever. Out of 15,000 satellites, less than 3,000 will remain. Humanity's space infrastructure will be reduced by 80%. It will take years to regain lost opportunities. Billions of dollars of investment will burn in the atmosphere. Entire industries will be on the verge of survival. But the lesson will be learned. Kessler Syndrome will show itself in a new form. Not through collisions, but through the natural power of the sun. Humanity will understand, space does not forgive negligence. Each launched object must have a mission completion plan. The Earth's orbit is not a dump, but a valuable resource that needs to be protected. The night sky over the planet will gradually calm down. Shooting stars will become rare. Astronomers will breathe a sigh of relief. The space age will continue. But now more carefully, more responsibly. The fiery rain of 2026 will be a warning. A warning that can be written in burning metal on the black velvet of space. The only question is, will humanity have time to prepare? Or are we already on the verge of a catastrophe that cannot be prevented? The sun does not ask permission. It just does what it has been doing for billions of years. And we filled near-Earth space with thousands of tons of metal without thinking about the consequences. Kessler Syndrome is waiting in the wings. And that hour may come very soon.